Hello students. So let us start the second part of the chapter motion. In the previous video we have seen what is motion, how the motion is defined, what is relative motion, and most importantly what is the difference between distance and displacement. So in today's video we are going to cover what is the uniform and non-uniform motion and what is rate of motion. So let us start. First, uniform and non-uniform motion. Let us start to understand this terminology with the help of example. So here I have drawn two timelines. Let's say this is first timeline and this is the second timeline. So on the horizontal line, a time is, let's say, 0 second, 10 second, 20 second, 30 second, 40 second and 50 second. Now I am having two different objects, let's say two different car A and car B, and on two different timeline I have shown how does this both cars moves. So for car A, in first 10 second it is moving 5 meter, in second 10 second it is moving 5 meter, in third 10 second it is moving 5 meter, and so on. So in each interval of 10 second it is moving 5 meter, 5 meter, 5 meter, 5 meter and 5 meter. Now let us focus on the motion of car B. So in first 10 second it is moving 5 meter. In next 10 second it is moving 8 meter, in next 10 second it is moving 3 meter, then 2 meter and then 7 meter. So is there any kind of difference in the motion of car A and car B? Can you guess? Yes, here the motion of the car A is bit arranged, bit systematic, because in each interval of time it is moving 5 meter. However, while for car B, in each interval of time, that is in each 10 second, the distance travelled by car B is not exactly equal. It is sometimes 5 meter or 8 meter or 3 meter and 2 meter. So it is not equal. So here we can say that car A is performing uniform motion while car B is performing non-uniform motion. Okay. So let us see the definitions. So if an object covers equal distances in equal interval of time, then it is said to perform uniform motion. So here equal distances in equal interval of time. So car A is said to performing uniform motion. Now if object covers unequal distances in equal interval of time, then it is said to perform non-uniform motion. So same way, this is the example of car B. So in equal interval of time, the distance travelled by car B is not equal. So it is performing non-uniform motion. So is that clear? Is that understandable that how we can define a uniform motion and how we can define non-uniform motion? So you can take example of your table 8.1, which is given on the page number 100. Here it is. Okay, so on the page number 100 you can see the example is given, let's say a distance travelled by object A and distance travelled by object B. It is almost the same example which we have taken here. So here also you can say the object A is performing uniform motion and object B is performing non-uniform motion. So can you give some day-to-day example of uniform and non-uniform motion? Can you think, can you guess? Okay, generally we can guess, we can experience that in the day-to-day life the motion of vehicle, our car or our scooter, is generally non-uniform. And why is it so? Because let's say I have to go to the market. So when I start my, let's say, car, initially the speed of the car is very low, When there is a clear road, I will increase the speed. When there is a crowded places, I will decrease the speed. So speed may vary. So it is not like that I will cover equal distance in equal time. So generally in day-to-day life, we encounter with non-uniform motion. Okay, so is this topic understandable? Let us move further. Rate of motion. So what is rate of motion? Let us start with the example. You might be watching a cricket, and in cricket you might be come across some term that the bowling speed of your favorite bowler is 140 km/h. Another example is, let's say, if you enter any company, any organization or any society, you might come across the board that speed limit is 30 km/h. So what is the meaning of such terminologies? Okay. You know that different objects take different time to cover the same distance. Is that clear? Let me give you an example. If I have to go from point A to point B, which is 5 km away. Now, if I go with the cycle, it might take half an hour. If I go with, let's say, scooter, it might take, let's say, 15 minutes. And if I go with car, it might take 10 minutes. So, a different object take different time to cover the same distance. Here distance is same, but to travel that same distance, the time taken by different object, be it a cycle, be it a scooter or be it a car, is different. So how to define this? So rate of motion is defined as the distance travelled by the object in unit time, and which is nothing but the speed. So here the speed of the car is higher, a speed of the scooter is in between cycle and car, and speed of the cycle is lowest. So rate of motion is nothing but the speed. Okay. We also come across this thing, let's say in day-to-day life, the speed of doing work. If there are two students, one student is doing work very fast, and the same work done by another student is bit more time consuming, then we can say the speed of the first student in doing the allotted task is higher, while the speed of the second student in doing the same task, in doing the same work, is lower. So this is nothing but the speed. The speed can be measured in different unit. It can be measured in the unit meter per second, centimeter per second, and kilometer per hour. It is a SI unit. SI means System International. You would also have come across this term, kilometer per hour, in the odometer of your car or bike or scooter. So that that needle or that digital meter displays the speed of the vehicle. Okay. Now, sometime as we have discussed here, in day-to-day life, the speed or in day-to-day life, the motion is always non-uniform. Okay. So it is not advisable to measure the speed which is at particular distances or particular instances. Rather than that, we measure the average speed. So average speed is the total time taken to cover the distance is considered here. So total distance traveled divided by total time taken. For example, if any object, let's say car, has traveled 100 meter, and to travel the 100 meter, the time taken is, let's say, 10 seconds. So in numerator 100 meter is there, in denominator 10 second is there. So 100 divided by 10 is 10 meter per second. So that is nothing but the average speed. The notation of speed is small letter v, in the numerator distance s, and in the denominator it is t. Let us understand this terminology, average speed, with the help of example. So in this example, if let's say car traveled 120 km in 3 hours, then find its average speed. So we have now the formula. Average speed v is equal to s divided by t. So total distance traveled is 120 km Total time taken is 3 hours. So 120 divided by 3 is 40 km per hour. So average speed is 40 km per hour. Now, what is the meaning of this 40 km per hour? Can you guess? Is it so that from starting point of car till 3 hours, that means 180 minutes, the needle of the odometer always show 40 km per hour? No, it is not like. It is average. It may happen that car would have traveled more than 40 km, it is 50, 60, 70 km per hour, or it could have traveled at 10 km per hour or 20 km per hour. But in general, on an average, the speed of the car is 40 km per hour. Okay, you probably come across the term percentage. Let's say in one subject you have scored, let's say 80 out of 100, or in another subject 75 out of 100 and 65 out of 100. So you define the term percentage. Let's say your percentage is 72. Does it mean that you have scored exactly 72 out of 80 in each and every subject? No, it is not the case, but it is giving a in general idea that on an average your mark is 72 out of 100. So same with this average speed. So it does not mean that during the entire journey the speed is only 40 km per hour, but it will give us the in general idea. Is that now clear? Okay. Lastly, let us take the example, which is example number 8.1 given in your book. Okay. So on the page number 101, I read out the example. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? So very simple example. 16 meter in first 4 seconds and another 16 meter in next 2 seconds. So we have the formula for average speed. It is V is equal to S upon T. So average speed. Now total distance in numerator. So 16 plus 16 is 32. Total time 4 seconds plus 2 seconds 6. So 32 divided by 6 is 5.33. And here it is given in meter and second. So we will use this unit. It is meter per second. So average speed in this example is 5.33 meter per second. Okay. So I hope by watching today's video you will be clear with the topic what is uniform and non-uniform motion and what is rate of motion. Moreover, you will be able to now find the average speed of any given case. It may happen that the distance is given and speed is given. So by putting this mathematical term, you will be able to find time as well. So here 3 mathematical quantities there. One is V, one is S and one is T. If out of 3 any 2 quantities are given, you must be able to find the third one. Is that clear? Thank you very much.